Thank you all for coming. This is a great, amazing turnout. We were just saying we probably fire marshal walks in at this point. So today we have the pleasure of hearing from our very own Dr. Stith. So Brad here has been got his PhD from Wazoo, Washington State University in 1982, and he's been here ever since, doing amazing work since 1982, first as a postdoc until 87, and then faculty until now. It's pretty impressive to do your whole career in one spot, and there's a lot to show for it. 33 pubs on his CV and an immense number of student authors. When I looked at his CV earlier, that's sort of the impressive thing, and I think a lot of those students are here today, which is equally impressive, so they still like him after that. Current NIH grant, totaling about $500,000, which is pretty nice. So he's still bringing in the money and filling seats. A very strong record of service to the department too. I'm fairly new, and so when I look at these committee makeups, Brad's always seems to be there or has been there at some point in the past. That's pretty impressive to see. Presentations, all around the world, all around the country. Although I did notice several of your last presentations have been at ski areas. Steamboat, Keystone, Breckenridge. Clearly knows how to play the game. So, today we're going to hear sort of a capstone, in a way, talk of his ongoing and very successful career, specifically in fertilization. And I'm sure it'll feature a lot of your work, as well as a lot of Brad's work. So, give me a hand in welcoming Adam.
Thank you, appreciate that. And again, this is a very emotional kind of talk because friends, family, students from the 1990s have all taken time to either fly here or drive here for this talk, and that really means a lot to me. So what I'm going to be talking about is their work, talking about an academic career, and we just went through another iteration of the RTP document, and what can you expect, what can you hope for in an academic career. So I want to talk about that aspect also, not just the science. And again, this was when I was in Jim Mahler's lab at the Medical Center in Pharmacology, and of course those very stylish glasses. So I was setting style standards even back then. And of course the red and blue shirt, colors you're never supposed to join together. I was pushing the edge on that too. But these glasses, again, they're classic. They were ½ a pound of metal. I got the strongest ones because I played basketball at lunch. And also the glass was incredibly thick. Yes, I just saw you there. So incredibly thick. This wasn't the plastic lenses now. This was the true glass. These glasses weighed ½ a pound. I mean, it was just amazing how strong they were and how different they were. But they're still in movies and all kinds of things. So these glasses, very well, the major serial killers dominated. They wore that style. Up there is one, the BTK guy, I think. Paul Newman, of course, and all the other movie stars wore these kinds of very stylish glasses. And I said I wouldn't wear them, mostly because, with that thick glass and metal, I donated them to an observatory. So those aren't in existence anymore, but I do want to emphasize I've got something cooler. Where here's, of course, Brad Pitt and the emo guy. I found actually the sunglasses version of those glasses. You can see metal. Kind of makes me dizzy putting them on. Very cool glasses. So I was thinking I could give a talk with these glasses on, but they do make me dizzy. So, but these guys, that thick glass, the heavy metal, aviator / style. Basically TSA would probably take these and say they're a lethal weapon, or the airlines would charge baggage fees to these. They're so big and heavy. So I'm not going to be wearing those, but you can see how cool they are. Okay, so this is, again, we'll talk about science and also life and academics. This is a graph I saw in graduate school, and I said, wow. So I've reached the stage where I no longer work in the lab. I don't eat as much. Even travel, I'd say that's actually not accurate. I've been traveling more. And finally, I'm at the stage where all I do now is talk. So that's why we're here. Now I still have a couple papers to finish, so I'm going to be working in that sense. So measures of an academic career is teaching. Obviously, we're I think a good combination between teaching and research. But it's not just good teaching where you update your notes, you stay current, but also you hope to contribute to the literature on improvement, understanding of learning, and do that and make that kind of outreach to that in that field. Impact upon students, many of them again are here, can change your lives, change the lives of the students. This impact is one of the reasons I came here, because I wanted to know the names of my students. My old mentor at the medical center didn't want a dog, that was too much. He did get married, but no children, because he wanted to devote himself entirely to the lab. And he said, all I want are a bunch of postdocs lined up at the bench, working away. He had a sense of humor, and he was exaggerating, of course, but I wanted to reach students at more of the beginning level and impact them, not just get them as a postdoc, but also try and help students if they're interested in a career in science at the beginning. And many of the students have gone on to great faculty positions and fame as researchers. And my line has always been, I open the door for these students, provide them with some resources, but then they're the ones that walk through the door and really put in the hours, the time, the effort to be successful. But at least I had a door that I could open and help them along that path. Service, of course, not only reviews of grants, papers, service to the university, but also hopefully at the federal or scientific society level. And so we'll talk about that a little bit. Discoveries, how you quantify an academic career. Maybe not just simply the number of papers, but finding new steps in various fields. For us, it's new steps in fertilization, new steps in the action of glucophage or metformin, and finally new models of activation of SARC. SARC is a highly associated with cancer, so we're looking at how lipids will regulate this cancer-causing enzyme. So we'll go through some of the discoveries. In grants, not total money, but awarded grants are a measure of how many good ideas you had, how many insights you might have provided or breakthroughs, and then you build on that. So it really is a matter of trying to not just list the grants, but talk about in those grants what you've done, how you've improved, and what your models are. So grants, again, measure how many good ideas, plus of course writing skills have to be there too. Over my 30 years or so at UCD, now again, since going to the medical center, in 1981, I've been at the University of Colorado for like 38 and a half years, but 30 years at UCD, and again, I came in 1987, and up until last year, I had about 0.8 research papers per year. That's excluding the 2 teaching papers. And the cost of each paper averaged about $105,000. So this is my area of research, cell biology, biochemistry, lipid signaling, where those numbers are pertinent. We always, as scientists, want to put numbers on things. Talk about how much, not just whether something happens, but how much it happens. Early career issues at UCD was kind of comical in a way. Coming here, there was no lab for me because this building, the North Classroom building, was not finished, so I had no lab, and the setup money was $25K, which was, for a smaller institution, not so bad back then, but not really enough to start a full program on. I remember once when I got there, I said, well, biochemists, we use ice machines. And I remember the response was, well, why would you want an ice machine? We've never needed an ice machine before. I mean, I felt like for decades I was the only biochemist here at the university. But, you know, this guy was nice. He said, well, I have a small ice grinder about this big. It's green, and we use it to make ice for our martinis. You can have it. And so I said, oh, thank you. That's very nice. So for a period of time, that's what we had, is a little box like this that would grind up about a handful of ice. And we didn't make martinis, but we were able to use that in our experiments. Dry ice was a whole other story. But anyway, 1991, I got my first grant in 1990, and I was looking into a postdoc, and I remember talking to an administrator and saying, well, I'd like to hire a postdoc. And I said, what is that? What courses are they going to be teaching for us? And I said, well, they'll be doing research. And they said, well, you have to set up a full faculty research committee, you know, start with the university and the paperwork and get everybody together and have minority members on the committee and go to a full faculty search for the postdoc. Anyway, things have obviously improved tremendously over the years. New building, et cetera, and a lot more support for research. So I was trying to total up, again, going through numbers. The Council on Undergraduate Research is something I joined in '87. It is an organization that tries to help support research in smaller institutions. They've advised the NIH, the NSF on various grant programs. And we've gotten away from being more of an undergraduate, more into a graduate level institution, but this still is a great organization that helps people set up labs and obtain funding. With this organization over the last 20 years, I've mentored maybe 700 new faculty in 14 national workshops. We discuss how to write research grants, how to set up the research lab with less resources, et cetera. My most common advice has been, in addition to simple